Welcome to Brain Vision.
This question we are asked, for which value of n are these following graphs bipartite? So we have 4 cases here. We'll go over them one by one. First, the complete graph. It is clear that K1 and K2 are bipartite. We can, like K1 is just one thing, right? And K2, we do the obvious thing that keeping the two from different partite. After that though, K3, 4 and so on, we cannot make them bipartite because each vertices will be connected to everyone else. So that vertices should be its own partite, right? But that would mean everything else will have to be of the same partite, which is not the case because within these n-1 vertices we have like edges joining them. So all in all, they cannot be bipartite. So only n equals to 1 and 2 works in this case for complete graph. Next, cyclic. This is first I would like to say that C2n, so n is when the number is even, is bipartite always. We can always do that by just segregating them, like the adjacent vertex will be of different partite, right? But each of them, like we can just alternating between the two partite like this. We can always do this when the number of vertices are even. What happens when it's odd though? So if we consider that odd cycle is actually even cycle adding one vertices, right? If we have even cycle as bipartite, so we add a new one. This new one will join up on, it will be replacing some of the edges. But no matter which edges it replaced, we cannot decide on which partite we will put it on. So suppose we add this new one. Sorry. Now we will have a problem of this new vertex can be red, can be blue, because it's connected to both red and blue. And so we cannot assign a partite for this. This will be odd one out. And so, and this happen in any odd circle. We already have bipartite nicely in even circle. Adding one vertices will make them like non-bipartite. And so the answer should be like n even in this case. All right. Next is wheel. Now this is not bipartite for any n, because like in the case of complete graph, the middle vertex must be its own partite, right? Because it connects to everything else. Its partite must have just one vertices. But then it will mean everything else will be another partite. But that's not the case because we have these edges connecting them. And so we cannot have a bipartite graph. All right, the last one is n hypercube. So right away, it is bipartite for any n. Why? This is kind of like the event circle situation because the way it is defined, we can, like in the lower case, we can just see that, oh, it can be divided into two groups, right, as a bipartite. Now when we move up the number n, we can just alternate not just each vertices but each like component as well. So instead of blue here, we blue here instead, and have red one here. So essentially, any adjacent vertices will be of different partite, and we keep doing this throughout the whole structure. And you're gonna see that it can be done no matter how big the structure is, just going up one by one each step. And so it is always bipartite. And that is it for this video. Thank you.